Welcome to this video on electrolysis, presented by Arnold Villaro. You can reach me via email at arnoldvillaro@gmail.com. Electrolysis is the process where ionic compounds conduct electricity in solution form. It is carried out in an electrochemical cell. An electrolyte is a substance in which electricity is conducted in molten form. Examples include sodium chloride, copper chloride, sodium hydroxide, ethanoic acid, and hydrochloric acid. A non-electrolyte is a substance that does not conduct electricity in molten form. Examples are pure water, sugar solution, ethanol, urea, or alcohol. This diagram illustrates an electrolytic cell, showing the setup with the battery, anode, cathode, and the molten sodium chloride electrolyte. The cathode is the negative terminal of the battery or cell. Conversely, the anode is the positive terminal of the battery or cell. Water is a universal solvent and plays a critical role in electrolysis, as most ionic compounds dissolve in it. Being a polar solvent, water attracts positive and negative ions. Preferential discharge dictates that if multiple ions are attracted to an electrode, the one requiring the least energy will be discharged. Factors affecting preferential discharge include the position of the metal or ion, concentration, and the nature of the electrode. Regarding the position of the metal or ion, the ease of discharge for both cations and anions increases with less reactive metals. Cations higher up the reactivity series require more energy to gain back electrons, which means they are more difficult to reduce and discharge. Concentration is a key factor. If an ion needing more energy to discharge is present in a higher concentration, it will be discharged preferentially. For example, in the electrolysis of sodium chloride, hydroxide ions are discharged preferentially to give oxygen ions when chloride ions are at low concentration. However, if the concentration of chloride ions is much higher than that of hydroxide ions, the chloride ions are discharged first, as seen in the electrolysis of brine. The nature of the electrode also matters. For instance, using a copper electrode as the anode during the electrolysis of copper sulfate solution, neither hydroxide nor sulfate ions are discharged. Instead, when an inert graphite electrode is used as the anode, hydroxide ions are discharged, resulting in the production of oxygen gas. The electrolysis of sulfuric acid is often referred to as the electrolysis of water. The ions present for this process are H+ at the cathode, and SO4-2 and OH- at the anode. At the cathode, H+ ions gain an electron to form H atoms. The overall ionic equation for this reduction is 4H plus aqueous plus 4E yields 2H2 gas. At the anode, OH- ions undergo oxidation. The overall ionic equation for the anode reaction is 4OH- aqueous yields 2H2O liquid plus O2 gas plus 4E-. Electrolysis is also used in refining metals. For example, in the purification of copper, impure copper is placed at the anode, and pure copper is collected at the cathode. This diagram illustrates the setup for the purification of copper, with the impure copper anode and pure copper cathode in the electrolyte solution. During copper refining, the impure copper dissolves, which is oxidation, producing Cu+2 ions and 2E at the anode. Impurities settle at the bottom of the beaker. The Cu+2 ions are carried to the cathode through the copper sulfate solution via the electrolysis process. At the cathode, the Cu+2 ions change to solid copper through reduction, which is represented by the equation Cu+2 aqueous plus 2E yields Cu solid. This purifies the copper. Electroplating is the process of applying a thin layer of one metal onto the surface of another material through electrolysis. This diagram shows an example of an electroplating setup, illustrating the flow of current and the placement of the electrodes. In electroplating, the metal object to be coated is placed at the cathode, and the metal used for coating is placed at the anode. Consider coating a nail or spoon with silver. The nail or spoon is placed at the cathode, and the silver is placed at the anode. The silver dissolves, undergoing oxidation, represented by Ag solid yields Ag plus aqueous plus 1E at the anode. Impurities are collected at the bottom. The Ag+ ions are transported to the cathode using a silver nitrate solution as the electrolyte during the electrolysis process. At the cathode, the Ag+ ions are reduced to silver solid, coating the nail or spoon. This is represented by the equation Ag plus aqueous plus 1E yields Ag solid. The applications of electroplating include making metals more lustrous, attractive, stronger, and durable. Electroplating is also used to protect engine parts from damage due to high temperatures and to prevent metals from corrosion or rusting.